Lesson 15.2 is finding two-sided limits graphically. And there's 4 different things that we need to talk about of if a function is continuous, that means there's no breaks at that x value we're looking at. There's going to be some different discontinuities we'll look at. We'll just start with number 1. And what's going to have is you filling out these 4 different boxes, and they have to do with limits, except for the last one. But we've got as x approaches -2 from the left, and we're going to have as x approaches -2, so same value, but coming from the right. That's our one-sided limits that we did on the first lesson. So let's look at where x is -2. Right here. So you'll notice that just when x is -2, there's no breaks or jumps or anything. It's just a continuous function. So as we come from the left, I'm approaching a y value of 3. As I come from the right, I'm also approaching a y value of 3. So I would say that both of these limits are approaching 3. If both of these approach the same value from the left and the right, then this limit, this is called a two-sided limit, has a value of also 3. So again, we have to have from the right and the left being the same number to be able to put that number here. If they don't match, then this limit does not exist. Okay, then we have this function notation is f of -2. So that asks, when x is -2, what is y? Well, since this is a line, which means there's points that exist all along here, we can also put that it's 3. But if this would have been an open circle, there would not have been a point that existed there, and we would have put undefined. So that one's the easiest one because there was no breaks or jumps or holes or anything. Now let's talk about an infinite discontinuity. An infinite discontinuity really means an asymptote. And an asymptote is some kind of vertical or horizontal line that a graph gets close to touching but never actually touches. And so we're approaching x is -2. That's our number in question here. So look right here when x is -2. See how these end behavior, the ends get really, really close to this line, but they're never actually going to touch. That is our asymptote here at x equals -2. So if I were to say, what is my limit as x goes to -2 coming from the left? So I'm following this end. Well, since this arrow goes down and down and down and down forever, my y's are getting smaller, 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 smaller forever, and so I would say that's going to -infinity. It's never going to stop at -100 or -1000. It just keeps going in that direction. If I go -2 from the right, I'm going to follow this end, and I'm also going to go down, 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 down forever. My y's are getting more negative, so I put -infinity. And then let's talk about this limit as x approaches -2 just in general. Since both of these ends are going down, we can say that the limit as x is approaching -2 from the left and the right, since these match, is going to be -infinity. But let's just say, for instance, one end went up and one end went down, and you still had a vertical asymptote. I would say this limit from the left is going to positive infinity because y's are going up. This end would be -infinity because they're going down. Well, then this general limit, I would put does not exist because they're not approaching the same value or this going the same direction. But because these match, you can always say the general limit exists. Okay, f of -2. That means when x is -2, what point do I have? Nothing. I have nothing, so it's undefined. So whenever a value does not exist, it's undefined. All right, number 3 is called a removable discontinuity. So a removable is just like how it sounds. You removed a point. So let's look at the number here in question, which is approaching +3. And this is continuous other than this open circle. So it means a point does not exist there. That right away tells me when x is 3, there's nothing. So this is always also undefined. I'm going to put that removable means that there's a hole at that number. So when we approach 3 from the left, that means coming from this way, Even though there's a hole, the limit exists, and that is a y value of -2. Coming to 3 from the right, y is also -2. That means that the overall limit exists, that the left and the right match, and that would be your answer. Okay, and then the last one. Last one is called a jump discontinuity. It's just like what it sounds like. It's a jump from one height to another. We're looking when x is approaching -6, and that is right here. So you can see this jump. From the left, this point here is approaching a y value of 1, whereas from the right, following this piece, x is way up here approaching 5. Because these two numbers are not the same, I say that this does not exist. You see a D and E button? That stands for does not exist. There is no limit because we're not approaching the same value from the left and the right. Looking at f of -6, is there a closed point or a line at x is -6? Yeah, right here, and that was 1.